The Symbian OS itself has a low RAM requirements because, as you know, it is an embedded system, and during that time, uh, the RAM is very slow to all the mobile phone. And portion of a memory are composed of non-volatile part, the ROM and the RAM, random access memory. ROM is limited only to 8 MB, so that's why the kernel chooses to have a nano kernel, so to be able to have a small piece of code in, will be fit in the 8 MB. And the RAM up to 64 MB, and in the latter part of the Nokia phone, uh, the RAM upgrade up to 4 MB. Kernel is usually loaded in a separate area of the memory or those non-volatile type. The kernel executes at ROM area without loading into the RAM, which is protected from the access by application program or less critical part of the operating system. And then other application loaded into RAM to execute. And access speed of RAM determine the application performance or speed of performance. For example, a multimedia, it uses a lot of RAM for image and video processing. And for the CPU, uh, all Symbian OS only runs at the ARM processor. Uh, ARM means Advanced Risk Machine, or yung RISC is a reduced instruction set computer. Is a processor that is running instruction set in a fewer cycle per instruction as compared to the more complex instruction set of non-RISC processor. The RM processor are designed to perform smaller number of instructions so that they can operate at higher speed, performing more million of instructions per second. That is why the kernel is a priority-based single task uh, kernel, and its ability to communicate instruction to the CPU is very crucial to the operation of the operating system. Also, a Symbian OS is a 32-bit microprocessor. To be able to understand this, I draw a separate diagram for this one. So the kernel uh, is primary task is to allocate the instruction to the CPU, particularly in the register area of the CPU. Yeah, single task siya. So, per task yung pagbibigay niya ng uh, uh, instruction. No? And then the CPU accepted through the register, and then the debug area describe how the processor or how the information will be processed. And then, of course, uh, it is all be synchronized. That's why it is a clock. And then the arithmetic logic unit, the 32-bit arithmetic logic unit, wherein the instruction is keep and instructions are being processed uh, in terms of binary format. And then some of the already finished process instruction will be cached into level 1, and the ARM processor has a level 2 cache wherein the in process instruction will be going to the bus interface for display at this screen, or with it going muna to the memory for another process before going to the display. So that's particularly the uh, participation of kernel in the processing instruction. So if we summarize the Symbian, this particular schematic diagram will be its most simplest form. Here we can see the at the center, of course, the application, and this is where the Symbian kernel also uh, reside on uh, in the memory here, and we have here the processor, the memory. As I said, this is an embedded system, and you have the modem for the signal, and that's why it is like linked into the SIM, and the power and audio, the battery, microphone, the speaker, you have the keyboard and the LCD.